So we've shown a little bit about mobile app services and how that enables some great functionality on the back end of your mobile applications. But what about the front end? What about the actual application development itself? Now, this might seem like a bit of a strange discussion in the context of Azure, but enabling rapid cadence into Azure and into the back end is going to mean that you're going to need a more rapid cadence for delivering your front end, your actual apps themselves. And that brings us into this dilemma for mobile app development. And if you've ever done any mobile app development, you'll have come against this dilemma. Do we want a great user experience, or do we want productivity as we develop the app? Do we want native apps? Well, if we want that side of things, we're going to have to develop in very platform-specific manner. And that means that we're tied into a single platform, or if we want cross-platform, we're going to have to duplicate a lot of code. So what happens with native development is you get these silos where you're developing apps for iOS, for Android, and maybe for Windows on the .NET platform. They give great platform experiences, they give full performance, and they have native service integration to those devices. However, as a developer, only the server-side components can be used. You're not reusing the application code itself. Your dev experience is different for each platform. So you have to either learn 3 different platforms, or you have to have 3 different development teams that are actually developing the same application. The other way to do things is to go to the hybrid and web model. And on the hybrid and web model, you have tools like Cordova, which allows you to work across devices because you're leveraging web and HTML and JavaScript, which is great from a developer point of view because you're leveraging those skills within your team. However, there's a performance trade-off usually, and sometimes those web applications don't actually even give you access to all of the services that are available on those devices. And so you've got this trade-off of, do we want full native capabilities, or do we want cross-platform capabilities? And that's something we shouldn't have to choose. So what is the solution to this problem? Well, that's where Xamarin comes into play. So Xamarin allows us to create native apps with beautiful UIs and native performance for Windows, Android, and iOS. And we're doing it with C#. So we're actually coding in C#. So if you've come from a .NET world, this is fantastic because you're developing in a language and in a paradigm that you're very used to. Now, one of the things to note about Xamarin is though you're coding in C#, you get 100% coverage on all of the native APIs across Android, iOS, and Windows. So this is not some scaled down set of services and capabilities for mobile applications. The Xamarin libraries cover 100% of the APIs in all 3 of the platforms. So this is great because we get this mix, we get all the benefits of cross-platform capabilities, but we also get the benefits of platform-specific. So we get full access to all the services. We get full performance because the code is actually native code, even though when we're writing it in Xamarin, it's in C#. And so Xamarin just enables us to develop these cross-platform apps that can consume these great mobile services on Azure, and we're not recoding, we're not getting separate platform-specific teams. We're able to reuse a lot of our code and to really maximize on the cross-platform capabilities through using Xamarin. So once we've developed the application using tools like Xamarin, we want to go through how do we actually release these applications. So what does the life cycle look like for releasing these applications?
I love it. You're talking my language now. This is the DevOps piece, and although his title is DevOpsologist, we both love that space. Here's the mobile app lifecycle, and I'm going to focus on the Microsoft stack, but we can plug and play lots of different things into this stack. So the Visual Studio Team Services is the first of these. It's where we're going to be doing our coding. It's a Team Foundation server in the sky, a cloud-hosted version called Visual Studio Team Services. Absolutely love it. But if you wanted to, again, you could swap that out with GitHub or with Bitbucket or some of these other areas. We go into app testing. In mobile space, app testing is not a trivial undertaking. There are hundreds upon hundreds of commonly used devices that need to be tested against potentially. So with something like Xamarin Test Cloud, you're able to offload that test up into Xamarin Test Cloud where you're running on physical machines, but you're running on someone else's physical machines. So they can be shared and the cost can be allocated across that. But now you've built something, you've tested it, you need feedback. Remember that very fast feedback cycle? Where do you get it? Hockey App. Hockey App allows you to deploy beta pieces of your code, or beta versions of your code, right onto people's phones. So they can, on their phone, get the latest version, be using that version, and give you feedback in this very rapid cadence. From there, we're going to let our customers install and use that application, and then we need to gather telemetry. Luckily, Hockey App's in play here as well, and things like application insights to grab that data. And the most important part, again, is that feedback cycle is we're going to take it and bring it right back in to our backlog in Visual Studio Team Services to determine what we're going to build next to start that cycle all over one more time. That's that mobile app lifecycle with Microsoft, and when you combine it with things like getting the Xamarin to build your on-premises, on-premises is the wrong word, your front-end application, and then driving that through with Azure, you get this very, very fast cadence that we all want when we're moving to the cloud.
So what I'd like to do now, Steve, is give you a quick demo of what Xamarin looks like. We've got a project that has some shared code between an iOS application, an Android application, and a universal Windows platform application. So I want to show you how Xamarin allows us to do that.
So I have Visual Studio open here, and I've got the Azure Kit mobile solution open. Let me just pin that. And so there are actually 4 projects within the solution. There's an Android project, there's an iOS project, and there's a universal Windows project. And then there's a portable project. The portable project is the shared logic. This is where the bulk of the logic for the application actually lives. And that portable library is shared between the other applications. And so you can see I've got some models here, like the main view model, settings view model, and so on. There's a couple of views here. These are XAML views. So if we open up the settings XAML view, this is just a XAML file, and I'll be able to register for data binding and for event notifications and commands and all of the good stuff that C# developers are used to with XAML. But these views then are referenced in the Droid application, in the iOS application, and the UWP application. For scenarios where it makes sense to have native code, for example, handling notifications, which is device specific, we've created a notification manager interface in the portable class, which is shared, and then that is implemented device specific in the Droid, iOS, and UWP projects. So for example, in the Droid project, there's a Google Cloud Manager service class which implements the notification manager interface. So again, we're sharing this code, we're sharing the logic from the portable library to the other device-specific projects. And not only are we sharing code, but we're actually even sharing views from the portable library across to the other device-specific projects. So let me run the Android application. So I'm going to run that in my emulator, and the emulator is a small virtual machine that gets installed and configured, and so we can actually run that application, and I have a breakpoint set in for the login. So once this is deployed out, if I look at the output, you can see that it's actually pushing that compiled package, the APK, to the emulator and then running in the emulator. So the application is running, and in order to hit that breakpoint for the sign-in, I'm going to click on the little sign-in icon at the top, and that's going to authenticate. I have got cached credentials, so it's not actually going to prompt me in this particular instance, but you'll see that we do hit the breakpoint. And from this point, we can use any debugger features that we're used to, like watches and locals and so on, and we can inspect the objects that are in memory and so on. And so this has given you a very, very small flavor for the power and capabilities of Xamarin development, being able to share application code and being able to debug cross-platform applications right from within Visual Studio.